In this lecture, we will learn how to take partial derivatives. Partial derivatives are used when we want to take derivatives of functions that depend on more than one variable. Let us look at a couple of examples and then the process of taking partial derivatives will become clear. Example 1. Let us start with a very simple example. Let the function be given by two variables x, y. It's a product of x times y. I want to take the partial derivative of f of xy with respect to x. Dou by dou x f of xy. This is a symbol that is used when we want to represent a partial derivative. Substituting what f of xy is in here, we get dou by dou x of xy. Now, this is a product of two functions. So therefore, we will use the traditional product rule of derivatives and write as dou by dou x with respect to x times y plus x dou by dou x. Now, the first term, that is this term, will give us 1. That is, we will treat this as an regular derivative. The derivative of x with respect to x is 1. So therefore, we will get 1 times y. Now let's come to this second term. You will notice that the derivative variable is x, but the function is y. So when we are doing that, we treat y as a constant, and derivative of a constant is equal to 0. So therefore, this derivative will give us 0. So finally, the answer, the partial derivative of f of xy with respect to x is equal to y. Now let us use the same function and calculate the partial derivative with respect to y. As before, we can write this as dou by dou y of x times y plus x times dou y by dou y. Here, in the first derivative, x is to be treated as the constant because the variable of derivative is y. Derivative of a constant equal to 0. So therefore, the first derivative gives us 0. So therefore, 0 times y plus x into dou y by dou y, which is nothing but 1. So therefore, the partial derivative of f of xy with respect to y is equal to x. Let's look at one more example. Example 3. F of xy. Now let us choose f of xy to be of the form x square y. Now I want to take derivative of f of xy with respect to x. So therefore we can write it as dou by dou x square y, which once again using the product rule can be written as dou x square by dou x times y plus x square dou y by dou x. Now dou x square by dou x is nothing but 2x, where we have used the formula x to the power n. So this gives me 2x times y. And the second term, you will notice, is 0. So therefore, the derivative of x square y with respect to x is equal to 2xy. Let's continue with one more example. Let me take x square y derivative with respect to y. That is the partial derivative with respect to y. Once again, using the product rule, we can write dou by dou y x square times y plus x square into dou y by dou y. Since x is to be treated as a constant, x square will also be a constant. Therefore, this term will give me 0. And as before, the second derivative will give me x square times 1. So therefore, the partial derivative of x square y is equal to x square. Now let us look at some examples wherein three derivatives are involved, or rather three variables are involved. So this is example number 5. Let's start with once again a very simple example, x, y and z. I want to take derivative of f of x, y, z with respect to x. So therefore we can write dou by dou x, x, y, z. Now this can be written as dou x by dou x times yz plus x dou y by dou x times z plus xy dou z by dou x. This term gives me 1 times yz plus, since y is the variable and we are taking derivative with respect to x, this y has to be treated as constant. So therefore we get x times 0 times z plus xy. Similarly here now z will be treated as the constant, and the derivative of any constant with respect to x is equal to 0. So therefore my answer is yz. Let's take the derivative of xyz with respect to z. I will leave it as a homework for you to calculate what is the partial derivative of xyz with respect to y. Let's write it out. So dou x by dou z times yz plus dou y by dou z times z plus xy dou z by dou z. Since the variable of integration is z, this gives me 0, this gives me 0, this gives me 1. So therefore the answer is xy. Now let's look at a slightly more complicated example, that is function of a function type of scenario. Let's say I have a function sine of x square y z. I want to take the partial derivative of this function with respect to x. So let's do that. This can be written as dou by dou x of sine x square y z. Now we know that the derivative of sine of x is equal to cos x. So what we will do is we will write it as, so you take derivative of sine, we get cos, then x square y z times partial derivative of x square y z. And as before, x square y z, we have seen in the previous examples and the above examples, we can treat the variables yz as constant. So therefore we can write this as cos x square yz times yz, because they are to be treated as constants, times dou x square by dou x, which can be written as, after taking the derivative here, can be written as cos x square y z times yz times 2x. Let's look at one final example. We will take the same sine x square yz and take the partial derivative with respect to z. So, this is example number 7. Example 7. I want to take the derivative of sine x square yz with respect to z, partial derivative. Therefore, dou by dou x sine of x square yz is equal to cos x square yz times, now we take the derivative of the function that is inside here. Dou by, sorry, this I want to take derivative with respect to z. So dou by dou is z x square y z. But x square and y are to be treated as constants. Therefore, we can write it as cos x square y z times x square y dou by dou z of z. But this gives me 1. So therefore, the final answer is cos x square y z times x square y. So I will leave it as a homework for you to take the partial derivative with respect to y. A final example, I think this should be good for you. Example 8. Let's take a log function. So let me take log of x square, y square and z square. I want to take the partial derivative of this function with respect to y. So therefore, I write it as log x square, y square, z square. Derivative of log of x is equal to 1 over x. So this gives me 1 over this function, which is x square, y square, z square times dou by dou y of x square, y square and z square. Once again, we will treat x and z as constants. Therefore, we can write it as 1 over x square, y square, z square times x square, z square, partial derivative with respect to this. Immediately, we'll notice that x square in the numerator and denominator can be cancelled. Similarly, z square can be cancelled. Y square gives me a 2y. So let me write this 1 over y square to 2y. Y cancels. So therefore, the answer is 2 by y. So I suggest as a homework, take the derivative of log of x square, y square and z square. Take the partial derivative of this with respect to x and also take partial derivative with respect to z. I hope this lecture helps you in becoming comfortable with partial derivatives.